those project networks that we started drawing the other day. I'm going to introduce a few new terms in this lesson, so do let me know if I'm going too fast. If you're not sure what I'm talking about, just pop your hand up and either ask a question or I'll just try and rephrase. So we want to know how long it takes for an activity to finish. And when we do that, we talk about a minimum completion time. So what we're saying in those cases is, at best, what's the shortest amount of time that this project will take? Now, obviously, in reality, quite often projects will take longer. Things will be delayed. There might be, say, rain, so you can't do a certain activity in the wet. So then the activity network or the durations will change. What we're going to look at is just what is the duration as it stands, and next week we look at a different technique called crashing, and that's when we're going to make some changes to the durations. So today's focus is how long does it take at best to finish that project. Now, to do that, I'm going to start talking about something called a critical path. The reason we're going to look at this thing, the critical path, is that is actually going to give you the answer to that question. The critical path is going to tell you how long it takes. We're going to do that first by looking at an example, a real life example, hopefully so it makes sense, and that is to look at making a coffee, making an instant coffee. That's the project. We want to know how long it takes. What's the minimum completion time of making the coffee? So we've got our activities listed, as you can see. There's a few different ones there. And the durations, that's in seconds. Notice, well, you hopefully can have a look and see what takes the longest in that list. Boiling the water, excellent. So often if you're making a cup of tea or a coffee, you might flick on the kettle first because you know that that's going to take the longest. While that's boiling, you might be, say, getting the cup, getting the tea bag, the sugar, the milk, whatever it is. Would you agree? Yep. So what we want to do is have a look at what this looks like on a network, so on a diagraph. Here it is under here. It's drawn for us already, but as you can see, no labels. So we need to identify which activity is which, or which edge belongs to which activity, and start to draw that onto the network. So you should have a pen in hand. Let's mark on perhaps just the start and finish vertex to start off with. So I'll do that now. Let's get a pen. So there's our start. It's a little bit slow. And finish. Maybe I'll just go FI. The start and finish vertex. Sometimes it's easy to work from the finish vertex with these. The only reason I say that is at the moment we've got 3 possibilities for these particular activities. It could be A, it could be C, or it could be D. How do I know that A, C, or D are coming from here? Excellent. They've got no predecessors. There's that little dash on the predecessor table. So if I maybe start from the end instead, and then I can start to piece it together, what there might go to the finish? What might be the last activity that is completed? G. Good. So I'm going to label that as G. And of course, we put the duration on as well, so comma 3. If you have a look at G, what's its predecessor? F. So this has to be F. And that takes 5. And then, of course, F has got either B or E as predecessors. So we need to just work out which one would be which in this case. So have a look at your table and just see what might be the right one. So F needs B and E. So it's going to be one of these two preceding F. Have a look at E. How many predecessors does it have? 2. So that means that this one would need to be E. It's got 2 predecessors before it. That can't be E there. Might need to highlight it on here. That one there can't be E because that would mean it's only got 1 predecessor. So just by having a look at a couple of things, you can actually fill this in. This is B here, taking 300. And that means that this one, of course, is E, which is 5. And you've got C and D. It actually doesn't matter which one you label here. And D, 5. There we go. Okay, so we've got our graph. And remember, we're asking ourselves, what or how long will it take for this coffee to be made? Now, the procedure we're going to go through is we're going to look for this thing called the critical path. The critical path in a digraph is going to be the path that is the longest, so it has the longest duration from start to finish. So a path, of course, is any route that we can travel through to get from here to the finish. So a possible path might be D, E, F, G, C, E, F, G, or A, B, F, G. They're all paths through the network. If we find the one that's the longest, as in we add up the capacities, or not capacities, we add up the durations on those edges, and we find the total that's the largest, that is our critical path. That is going to actually tell us how long it will take. Can we do that now? Find the path that's the longest? Once we've done that, I'm going to explain why. In reality, why is it that it's the longest path? It shouldn't take you too long. What's our path? What's our critical path? A, B, F, G. It's pretty obvious, isn't it? Because you've got that 300 there. Now, the length of time, if we add that up, we get 318. So that's 318 seconds. Just put an S for seconds. 318 seconds it takes to complete making that coffee. Now, why is this? Why is it that it's the longest path? You consider that we have predecessors. Remember, predecessors are those activities that have to finish before another one can start. Take a look at activity F. What is activity F? It says, pouring the water into the cup. Now, it only takes 5 seconds to do that, but it can't start until our water is boiled. You know this, if you're making a hot drink, you're not going to pour it in when it's cold. You've ruined it, you're going to have to start again. When you're making a hot drink, you wait for that kettle to boil before you pour it into the cup. Just like when we were talking about I think there was one with a recipe in the video that I left for you on Monday, you wouldn't actually put the cake into the oven until it was preheated, or until the mixture was actually ready to go in. If we understand that concept of a predecessor, of something having to finish first, then we understand as well that the first opportunity you have to pour the water into the cup is after 310 seconds. Because have a look up here, it's going to take you 10 seconds to fill the kettle. It's going to take you an additional 300 seconds for it to actually boil. All this stuff down here, that's going to happen while it's boiling. That's all going to happen at the same time. So it's not adding any duration. What is taking the longest here is boiling the kettle. So that is the biggest determinant on the minimum time. You're looking for the activities or the paths that's taking the longest to complete. Everything else will be held up by those activities. It will be held up until they're done. Then F can start, which takes 5 seconds, and then stirring, which takes 3 seconds, and then your project is complete. So at best, we can't do this any faster. We can't do it any faster because F's not happening for 310 seconds. The reason some of you might be thinking, oh, this is so logical, like why are we discussing this so much? The reason I need to go through this clearly is when we talk about minimum completion time, lots of students will confuse that with minimum path. They think minimum completion, minimum path. And then, of course, they're doing the opposite of what we need you to do. If you have a look at this, you'll be able to see it's not possible using the minimum path to make that coffee. So if you have a look at the minimum, it's going to be the 5, 5, 5, 3. We've got 18 seconds. Just logically, you can't do it in 18 seconds. Unless you've got a really, really good kettle, it's going to reduce the boiling time very much down from the 300. Okay? It's not possible looking at the minimum path. So I know we've had lots of different terms with this topic, such as the minimum cut is the maximum flow. We've had the shortest path through a network. What I would suggest you do before you do the SAC is just some key terms, key concepts, critical path, longest path, minimum completion, things like that. Just linking those things together just to avoid any confusion. So, critical path ABFG, 318 seconds. Another point I'll make is that any activity that's on the critical path, we call them critical activities. So, the reason it's critical is because if you delay it, so if boiling the kettle is delayed, so say you think you've turned it on, but you hadn't switched it on at the wall or something like that, say there's some sort of delay to a critical activity, that is going to delay the whole project. There are other activities on there that are non-critical. They're non-critical because you can delay them. Look at activities C, D, and E. You've got a lot of time up your sleeve while that kettle's boiling. So you can take your time with those activities. They don't have to be done in the 5 seconds that it takes each of them. You can extend it out for a little bit until, of course, the kettle's boiled, then you want to have your cup and your milk and sugar ready. So critical activities, you can't delay them without delaying the whole project. Non-critical, you can. Only to a certain extent, of course. You don't have infinite time because the kettle will eventually boil. Let's just list those critical activities. They're just the ones on the critical path. So they're going to be A, B, F, and G. And just that last point there, if the duration of these, so the length of time it takes, if you increase it, what will happen to the minimum completion time? It'll go up, it'll increase. Good. What we just did then was finding the critical path, so finding the minimum completion time, and we did that just by inspecting the network. That's actually a valid way to find the critical path. There's nothing wrong with finding it that way. The issue, of course, is we're not going to be just asked, generally, we're not going to be just asked about that. We're going to be asked lots of different questions about the activities that are going on. So we actually have 2 different techniques to finding the critical path. That first one, by inspection, we're going to have a practice with that with a couple of different networks before I start to show you the second technique, which is scanning. We call it forward and backward scanning. Today, all I want to cover is the forward scan. We're going to break it up, only because it's quite new. It's very new, in fact, to you. I'm going to break it up and just do it one tiny piece at a time. Let's first just have a go at the inspection technique, because I would recommend using this technique when the only thing you need to find is the minimum completion. So you might have a multiple choice question in your exam, say, or in your test that's coming up, and in that particular question, it might just say, what's the minimum completion time? If that's the case, you don't have to go through any longer process to find it. You can just find the longest path. So sometimes it's actually quicker to do it this way. It's also important just to reiterate that it will always be the longest path. When we start to do a technique next week where we change durations, this is what I'm going to go back to. I'm going to go back to just looking at the network and finding that longest path. So let's just have a go with a few of these here. This one here is pretty easy because there's only a few paths available. Here's your start vertex over here and your finish down there. So So I might just make a note up here. You can use this technique Sorry, my pen goes a bit slow when it's recording, so it struggles a little bit. You can use this technique when only finding minimum completion. I'll just say min completion time. So just fix that up a little bit. Okay, so what I want you to do is list the paths just on the side there. List the paths that are possible from start to finish. What have we got? We've got A, C, F. That's one path. We've got B, D, F. And B, E. Obviously, some networks will be a lot larger and there can be lots of different possible paths. In those cases, I probably wouldn't use this technique. I'd use the other one that I'm going to show you shortly. Okay, what is the length of ACF? 28. So all I'm going to do now is go through my list, tally up the totals and see which one here is the longest. What about BDF? What do we get? 26. And BE, very short, 13. Good. So, very quickly, I can see which is the critical path. Critical path is the longest path. So the top one, yep, ACF. Now, I think in the question at the top it says the durations are in days. So what I can say is the critical path is ACF. And this is happening, so the minimum completion is 28 days. There we go. So often you'll be asked for not just the critical path, but what is the actual minimum completion time. So make sure you give both of those if you need to. Just two more that I want you to try. So I'm going to get you to try them now. The next two are actually from the car exams. Now you see the font and the way that the edges are drawn is consistent across all of the exams, so you will start to recognise them. The next one down here, let's just make sure we know the different paths and then you can have a go at finding which one is critical. We've got A, B, D, G, H. Or if you go A, B, and then E, F, H. So that's the second option, or A, C, F, H. Yep, sure. Okay. Once you've identified your critical path, we just want to state what the critical path is and what the minimum completion time is. One thing I'll mention before we do the last one is if you have a look at this one, before I even start looking at the paths, I can immediately see that there are a couple of activities that are critical without even looking at the paths. Which two, just looking at that, can you identify would absolutely be critical activities? No doubt about it. Even if the numbers weren't there, I know that it's critical. A is one of them, and H, well done. So sometimes there will be activities that, as you can see, to create a path from start to finish, you have to go through them. You have to go through A, you have to go through H. That means immediately I know that A and H are critical. I know the path is going to go through it, and have a look at the paths we wrote. They've all got A at the front, H at the end. So immediately I can see some of those critical activities. It would be a good question to ask students about that, to say give you one without numbers and say identify at least one critical activity. All right, last one. You've started it. Excellent. I'll do the same, and then we'll make sure that we've got the same answer. You might notice something a little bit unusual about this one. And that's okay, because I've done that on purpose. What do we notice? They're the same. Yeah, there's a couple here that are the same. So this is actually possible. You can have more than one critical path. There is no limit, so it is possible that you could have even more than 2, more than 3. All this means is there's less, or there are less non-critical activities. There are less activities in the network that could be delayed. So the more critical activities that you have, the more risky it is, obviously, because it's more likely you might get a delay. And if that delay happens on a critical activity, you're delaying the whole thing. You're delaying the whole project. So just know that it is possible. If you are asked, you can be asked sometimes to find the critical path, and then in brackets you'll have an S, just meaning if there's more than one, you need to state what the other one is as well. So we've obviously got this one and that one, so all you need to do is state that. The critical paths, plural, are we have A, F, H, and B, C, F, H, and of course that's taking 18 days. Are there any questions about what we've done so far? We're okay? All right, I'm going to start to show you a technique, the first part of it, the first half of it I should say, and that is scanning. Forward scanning is what we're going to do to start off with. Now, forward scanning is going to give you more information than our other technique. Our other technique just found critical path and it found minimum completion. Forward scanning is going to tell you the minimum completion as well. That's going to give us that. But it's going to give us something called the EST, the earliest start time. And we're going to get the earliest start time for every activity in the network. So that means, at best, what's the earliest that each activity can begin? Obviously, this is going to be determined by the predecessors and how long they're taking. So, Couple of things before we start this. There is a way of doing it. There's a way of showing your workings as well. And you'll see under here that I've done it for you already. I've given you some boxes. Notice this network. This is one we've already looked at. This is the same one as one on the previous page. There are now boxes drawn, double boxes in fact, so rectangles that are split in half, so that you've got two sections to enter a number into. When we do a forward scan, we are only going to fill in the left-hand side of each box. The second part of the technique is called a backward scan, and that's where we're going to fill in the second half, the right-hand side of each box. So just for today, we're only going to be putting numbers in the first half. Okay? So don't worry about the second half for now. Now, with these questions, you're generally not going to be given the boxes. I've just done that on here to demonstrate the best practice, to demonstrate to you what I want you to do when you draw boxes, and that is to get each box that you draw close to where the activity starts. So each activity has a box allocated to it. This box here is for activity A, so we're going to label a little A next to it. We're going to do that for all the other activities as well. So the box that represents the activity, it should be drawn as close to the start of the activity as you can. So this one you'll see is right at the beginning because A is at the beginning. This box here is for B, so I've tried to keep it close to where B starts. I've tried to keep C close to where C starts, etc. So this one here is for H, that one is for F. Notice how sometimes it's very close, they're very close together. You can't actually fit a box in there. All I do in those cases is I stack them on top of each other. So D is going to be the one on top because it's on top of E, and E will be that one there. That one there's G. Let's just first label them. So that's B, C, D, E. Labeling them is very important because they can get really messy. You can get a lot of busyness happening in your diagrams. It's so important that you know which box you're looking at and why. So G, H. Notice at the end there we've got a finish box. So we've got a box right on the end. That box there, when we get a number in it, is going to give you your minimum completion time. Which again, remember, is the length of the longest path. Minimum completion time. Make sure every single activity has a box. Dummy activities, you'll see in some people do a forward scan slightly differently to the way I do. I never do a box for a dummy because a dummy doesn't have a duration. So it's not going to have any effect. But it is important when there is a dummy that we make sure we follow that path. It creates another path, a dummy does, because we'll have an arrow on it. I do have an example with a dummy in it to show you what we do. Okay, I'm ready to show you how to do a forward scan. What we want to do, start from the left-hand side, hence why it's called a forward scan. We're going to work our way from the left-hand side all the way to the finish. When we do backward scanning tomorrow, we're going to do the opposite. We're going to start at the finish and work our way back. Okay? So just forward scan today. Find your starting activity. So find anything that's coming from the start. That doesn't have a predecessor, does it? Nothing's finishing before it. So that begins at time 0. It begins after 0 time has passed. That number that we're putting in is basically saying how much time's passed since the start for when this activity can start. So the earliest possible time it can begin. Let's work our way across. Have a look at B. What needs to be finished? A needs to be finished. So what we're going to do, every time you do a forward scan, you're going to look at the predecessor. You're going to look at the ESTs. You're going to look at this number that we've written. You're going to add the duration to that number. So 0 plus 5. B is starting after 5. Anything else starting at the same time as B? C? So we'll put the same number in. It's also starting after 5. So all it means is it's got to wait for A takes 5. We'll then start to work our way through. So, don't do F just yet, because there's something special about F. Let's have a look at D. Look at its predecessor, it's B. B's starting after 5, but then it takes 3. So what we do is we go 5 plus the 3. So D can start, at best, after 8. Same with E. We're basically adding up the path that takes us to that particular activity. The reason I said don't do F yet is, what do you notice about F in terms of predecessors? Good, there's 2 of them. Now this is one of the really important rules when you're doing a forward scan. When there are 2 options, there's actually 2 possible numbers we could write. Have a look. This could either be 8 plus 4 is 12, or 5 and 6 is 11. Now what do we know about minimum completion? Longest path. Longest path. So we need to put the longest path in here, so we need to put the larger number, 12. When there's a smaller number, you ignore it. You only place in the box the largest of the options. So it does mean that if there's 3 predecessors, you've got to check those 3 different options before deciding on the largest number. What do we think about G? G would be, have a look at it, so it's got predecessor here, 8 plus 5, 13. Beautiful. H, however, 2 predecessors. So we check both of them. We check G, that would be the 13 plus the 4, that would give me 17. Or over here, 12 and the 6, 18. So there we go. And finally, this is where we're going to get our minimum completion. H can only start at best after 18 days. H will then take 3. So at best, what's our completion time? 21. Now, of course, we did this same one before. We got the same answer, 21. This would take you a little bit longer, perhaps, than just adding up each part. But this is giving us some really good information, and we might be asked questions in regards to this. We might be asked, what's the minimum or the earliest start time for activity F? So I need to find that path that leads me to F and see which one is the largest. And that's what this number tells me. If you go that way, you get 11. If you go this way, you get 12. So at best, you're starting after 12 days. I'm not going to do the backward scan just yet until we've had much more practice with the forward scan. So we're going to have a go with this one here and one with a dummy over the page. Oh no, there's a couple more after that. So there's 3 more that we can have a go with for today. Okay, so let's get started. First thing will be to label the boxes. Sometimes the first thing for you will be to actually draw the boxes as well. You will have some practice doing that later on. So that's got to be B, that's got to be F, that's got to be C, D, H, G. Once you've got your labels, you can start having a go. You can follow along with me if you want to. Otherwise, you can move ahead and just glance up every now and then to check that we're doing the same thing. So, I'm not going to look at E and F yet because they've got 2 predecessors. So I'm actually going to start by working down here at C and D. They are going to start after 3, as B takes 3. Then I'll go up to have a look at E and F, and I'll see that this side I've got 0 and 7, so 7. This side I've got 3 and 4, which is also 7. So because I've got the same number, I didn't have to discard one of them. Or actually, the longest one is 7. So I place that in the box. Then you can work your way across the network. Over here, 2 options. 7 plus the 5 will give me 12, or 3 and the 4 would only give me 7. So obviously I'm going to go with the 12. Up the top to G, I've got 7 and the 6. And then I'm ready to find my minimum completion. I check both paths. So for G, it would be 13 plus its duration of 4 would give me 17. Other option, 12 plus a 6. My minimum completion is 18. Again, that's what we found when we just did it by inspection. That was the one that had 2 paths. We'll come back to that one when we do the backward scan. Any questions so far? No? Okay, I'll keep going. Now, what you've got there is the instructions for a backward scan. Let's just pass over it for now, not till tomorrow will we look at it. This one here is a big one. So I want you to have a go at this one and the last one, which we'll do over the page as well, which has a dummy in it. Alright, so let's label first. It's going to be A, C, D. That one there will be F. That one there will be L. This one is J, G, H, N. What's that one? That's I. Okay. All right. Once you've got it labelled, you can start. I want to zoom out a little bit so that I can get the whole thing in. There we go. Should be having a go at this one. Make sure you do look at the correct box. That's why we label them, so that there's no confusion. Last one. Okay, so we should get 15 for that one there. The last thing I want to do is just show you one with a dummy in it. There we go, there's one there. The dummy's coming after B. Now what's really important here is that dummy, it opens up more paths. By having a dummy there, it means there's a possible path that goes A, B, and then G, M, or A, B, H, I, L, M, etc. So when there's possible paths that open up, it means that there are obviously predecessors that we have to keep in consideration. When you do activity G, you must remember that B is a predecessor of G. Same with H. Let's have a look at it. See here? Because this is connected, it means that G is not starting until this happens. So until B finishes. So keep that in mind. So when you do G, you're not looking just at C, but you must also have a look up here at what's happening before it. You ignore F because that's happening at the same time basically. You look at what's finishing before G, and B is one of them. So just be careful as you start trying this one, and I'll show you as I do it as well. So I'm going to label them first. Let's get that out of the way. Okay, I've put the easy ones in. And now we're ready to have a look at the dummy. Just zoom in a little bit for you. Okay, where most of the mistakes will happen, the students will look at G, they'll just look at the predecessor, what they think is the only predecessor, C, and go 10 plus a 3, 13. But B's got to finish first as well as C. B has to finish before G because we've got that connection via the dummy. When is B starting? After 10? B's taking 5. So G and H can't start until 15. So these are actually going to be 15 here and here because of this dummy here, this connection. Once you've got that, you'll see that that makes I 19 because it's going to be 15 plus the 4 is larger than the 12 plus 5. We've got 19 there. We can then go, that's going to be 22. K up there just needs F to be completed. So that's going to be 24. 15 plus 9. Above that, we've got J. J's the same, 24. M has got 3 predecessors. You've got to check all 3. 22 plus 4, 26. G's 15, 15 plus 6, 21. K's 24 plus 1 is 25. The largest one, 26. So the 22 plus 4 gives me this 26. Finally, we check the last 2 options here. 24 plus 3 is 27. 26 plus 2 is 28. We should get 28 as our minimum completion time for this network. I'm going to stop this recording here. We're going to do some more practice on it. I've got a sheet for you with 3 that I would like you to try before tomorrow. There is time today to have a go at them. you can show them to me and I will correct it for you. I'll tell you whether